Alright, this is going to be test 2. And so I'll be writing these down as we go. So the first one, we have to express the rational expression in lowest terms. Alright, so I want to express that in lowest terms. So the first thing I'm going to do is divide this up. And so that's going to give me 8. This is going to give me that. And so I'm going to get that times that. And I think the instructions said only to use positive integers. Okay, so I'm going to write this as 8p over n cubed. Let's see how it likes that. Alright, perform the indicated operations and simplify the result. Okay. Leave the answer in factored form. Okay, after you simplify. So for this one, we're going to have x squared plus 10x plus 21 all over x squared plus 16x plus 63 times x squared plus 9x all over x squared minus 4x minus 21. So I need to put those together, and I need to factor and then do any cancellation. So I'm going to have, for the first one, two numbers that multiply together to give me 21, but add up together to give me 10. That would be 7 and 3. I can factor an x out of that. Two numbers that multiply together to give me 63, but add up together to give me 16. That would be 9 and 7. And two numbers that multiply together to give me negative 21, but add up together to give me negative 4. That would be negative 7 and positive 3. Okay, so I can cancel an x plus 3. I can cancel an x plus 7. And I can cancel an x plus 9. And so after cancellation, I'm going to have that. And to write this in WebWorks, I have more than one term in the denominator, so I must put grouping symbols around it. So I'm going to need x over x minus 7. Okay. Alright, so for number 3, continue with that. And then that's a division sign. Okay, so if there's a division sign, you change it to a multiplication sign, and then you multiply it by the flip, the reciprocal. Okay, now I can put this all into one fraction. I'm going to factor this. Two numbers that multiply together to give me 36, but add up together to give me 13. That'd be 9 and 4. Two numbers that multiply together to give me negative 35, but add up together to give me positive 2. That'd be positive 7 and negative 5. Two numbers that multiply together to give me 63, but add up together to give me 16. That would be 9 and 7. And Oh, these are all z's, my bad. And something I can factor out of that, I can factor out a z. So those should all be z's. I can factor out a z. Okay. And so the z plus 9s will cancel. The z plus 7s will cancel. And the z plus 4s will cancel. And at the end of it, I'm left with z minus 5 all over z. Now, if I'm going to put that answer into web work, I have more than one term in the numerator, so I have to put it inside parentheses. If you don't put it inside parentheses, it's not correct. Okay, so z minus 5 all over z. Okay, so let's continue. All right. So I want to simplify and leave the answer in factored form. Okay. So let me get this back up. I'm going to leave a bit of space. Now x squared minus 1 will factor. It factors as x minus 1 times x plus 1. So in order for all of these to have the same denominator, I'm going to need to multiply this one by x plus 1 over x plus 1. And I'm going to need to multiply that one by x minus 1 over x minus 1. And so I'm going to have 5x times x minus 1. I can put them all together now. Plus 6 times x plus 1. And minus 10. And now I'm going to distribute that through. Okay. And I'm going to have 5x squared minus 5x plus 6x is plus x minus 4. Okay, now how do I factor that? Well, for 5 I've got 1 and 5, and that's it. What could I have for 4? I could have, for negative 4, I could have 1 and negative 4, negative 1 and 4. I could have 2 and negative 2, or in that order, or I could have 4 and negative 1, or negative 4 and positive 1. Let's hope that I don't have to go through all of them. Now I want outer product plus inner product. Negative 4 plus 5 is 1, which is the coefficient there. So straight off the bat, I found how to factor this. So it's going to be 1 times x and a 5 times x there, and then a plus 1 and a minus 4. Okay, so after factoring that, I get that. And so my x plus 1's cancel, and I'm going to be left with 5x minus 4 all over x minus 1. Now, that is matching up with this guy here. Okay. All right, perform the indicated operations and simplify. Okay. Well, let's see what we've got for this one. Negative 9x minus 3 over x plus negative 6x minus 7 over 8x. So what I'm going to have to do is I'm going to have to multiply this one top and bottom by 8. And so I'll get 8x now in both denominators so I can put them together. And I'll have that. And plus negative 6x minus 7. Alright, 8 times negative 9x is negative 72x. 8 times negative 3 is minus 24. Okay. And so those two together are going to give me negative 78x. And these two are going to give me minus 31. And then all over 8x. Okay. So it's not the first one, because the first selection there has 8x squared in the denominator. This is going to match up with the last one. Okay, now I need to find the domain of this. Well, in order to find the domain, you need to factor it. And x squared minus 25 is going to factor as x minus 5 times x plus 5. And I can see x is not allowed to be 5, and x is not allowed to be negative 5. So that's going to be my domain. And so that's going to match up with this one. Okay, find the vertical asymptotes. Again, you're going to need to factor. X squared minus 16 factors is x minus 4 times x plus 4. Okay, there's no cancellation, so vertical asymptotes are found at real zeros of the denominator after any cancellation. There's no cancellation. So 4 is a 0 and negative 4 is a 0. Vertical asymptotes are vertical lines. So I'll have two vertical lines. Their equations are x equals 4 and x equals negative 4. Alright, give the equation of the horizontal asymptote if there is one. Okay, so let's write this out. Alright, so for the horizontal asymptote, I need to know what degree the numerator is and the degree of the denominator. I can go ahead and just multiply that through. So there were three cases you had to know for horizontal asymptote. Here, the degree of the numerator is 2, and the degree of the denominator is 3. And so the degree of the numerator is smaller than the degree of the denominator. That was case 1. And so that means that the x-axis is the horizontal asymptote. But this question asks for the equation. And the equation of the x-axis is y equals 0. So that's what we're going to put in here. Alright, now we want to find the hole in this graph. Oh, sorry, I didn't need to do that. Okay, so we want the hole. I'm going to need to factor, as always. The numerator will factor easily. Two numbers that multiply together to give you negative 5, but add up together to give you positive 4. So positive 5 and negative 1. And here, I'll have 1 times 2 for that coefficient. And here, my coefficients for positive 3, they're both going to need to be negative. So I can have negative 1 and negative 3. Or negative 3 and negative 1. Okay, now I'm going to do outer plus inner. Negative 3 minus 2 gives me -5, which is what I want. So again, I have found the one that will work. And so I'm going to have 1 times x here, 2 times x there, and then -1, and then -3. Okay, so the x minus 1's cancel, and I'm left with this, but I could only make this cancellation if x was not equal to 1. Okay, now I've got it in lowest form. Whenever there's cancellation, there is a hole. There is a hole. What is the x-intercept? It's that number there, 1. What is the y-intercept? You plug in 1 into the reduced form. So everywhere there's an x, you replace it with 1 in the reduced form. So I'm going to have 1 comma 6, and 2 minus 3 is -1, and so that's going to be 1 comma -6. That's the equation of the whole, of the coordinates of the whole. So I want 1 comma -6. All right. Again, what are the coordinates of the whole? Okay, so we've got x squared minus 5x minus 6 over x squared minus 3x minus 4. Two numbers that multiply together to give you -6, but add up together to give you -5. That would be -6 and +1. Two numbers that multiply together to give you -4, but add up together to give you -3. That would be -4 and +1. So I have cancellation, which means we'll have a hole. So in reduced form, I get that, but I could have only done this cancellation if x is not equal to -1. Alright, now, where's the hole? The hole is going to have x coordinate -1. What is the y coordinate? You plug in -1 to the reduced form. So I get -7 in the numerator, and I get -5 in the denominator. The negative signs cancel. That is the hole. So that's what I'm going to enter, -1 comma 7/5. All right. Now we want the equation of the oblique asymptote. We have degree 2 and degree 1. There is an oblique asymptote. So I can do this with synthetic division or long division. Synthetic division is quicker. Okay, I add, and 15 times 9 is 135. And then I add and get 128. That's my remainder, which I don't need. Those are the coefficients of the quotient. So that's my constant, and that's my x term. So the equation of the oblique asymptote is y equals the quotient. So it's going to be y equals 1 times x plus 15. That's the equation of my oblique asymptote. Okay. All right, there is no oblique asymptote for this one. You only have an oblique asymptote if the degree of the numerator is one more than the degree of the denominator. The degree of the numerator here is the same as the degree of the denominator. So there's no oblique asymptote. Find the x-intercepts of the graph. Okay. Just get my screen. Okay, so for this one we want the y-intercept of the function. So let me get my camera up. So f of x So for the y-intercept, we plug in x equals 0. So all of these terms go away, and I'm left with negative 8 over negative 2, which is positive 4. And so I do have a y-intercept, and that's the point. So 0, 4. All right. Find the indicated intercept. So I want the y-intercept. So if I plug in 0 for x, I'm going to get 8 in the numerator and negative 23 in the denominator. So my y-intercept is the point 0, negative 8 over 23. So that's what I'm going to put in there. Okay. All right, now we want the x-intercepts. Okay. X-intercepts are found at real zeros of the numerator after cancellation, and the numerator has no real zeros. So x squared plus a number will always factor, but not over the reals. So x squared plus 8 does factor, but we can see that the zeros are the square root of 8i and the negative of the square root of 8i. These are not real, so there are no x-intercepts. Okay. Now, on to the next one. Find the x-intercepts of that. Okay, so we have x squared plus 13x all over that. Okay, so the numerator will factor, and the denominator does not factor. But that's okay. So there's no cancellation, and x-intercepts are found at real zeros of the numerator. And there's two real zeros. One is 0 itself, and the other is negative 13. So I have two x-intercepts. Okay. And so that's what I'm going to here. Separate multiple points by a comma. Don't use any extra spaces. Okay. All right, we want to solve this equation. There's different ways you could do this. You could give them the same denominator. Or you could cross multiply. So this is going to give me, no, I think I'll cross multiply. Or I can get rid of the fraction. So I can multiply everything by 2x minus 3 times 2x plus 5. Okay. If I do that, I'm going to have those cancel, and I'll have 2x plus 5 times 6 equals, and then if I multiply this by this fraction, the 2x plus 5's cancel, and I'll get that, and now I just need to solve this. So I have 12x plus 30 equals 8x minus 12. Let's subtract 8x from both sides. And let's subtract 30 from both sides. So I have minus 42. So x is going to be negative 42 fourths. And press math and then enter to get that into lowest form. So negative 21 halves. And so that's matching up with that second one there. And finally, I need to solve that equation. So I have 2x. Now that will factor. X minus 1 times x plus 1 is equal to 3 times x minus 1 times x plus 1. Then minus 4 times x plus 1. Okay, to get everything with the same denominator, I'm going to need to multiply this one by x minus 1 over x minus 1. Okay, and that should, actually no, what I'm going to do is I'm going to get rid of all these denominators. And so what I'm going to do is I'm going to multiply the whole thing by x minus 1 times x plus 1. Every term, because I want to get rid of the denominators. Okay, if I multiply this, that cancels both of them out and I'm just left with 2x. If I multiply this term by that cancels out and I'm left with 3. And then here I have minus, and then 4, and the x plus 1's will cancel. I'm left with an x minus 1. Okay, now I can solve this. And then I'll have plus 4. I'll add 4x to both sides. And 3 plus 4 is equal to 7. So x is equal to 7/6. Now, only enter the final answer. Do not answer x equals as part of your answer. So I just want to put in 7/6. Okay.